In this video, we're going to look at the notes for applications of nonlinear systems. A child's rocket is launched and reaches a maximum height of 32 inches and lands 8 seconds after the launch. It's a safe assumption for these problems, since we're talking about nonlinear systems and we've only covered quadratic, that the rocket will be shooting in a quadratic pattern when we're talking about the height and the time. So it reaches a maximum height of 32 and lands 8 seconds later, which means that the vertex for this is going to be at 432. So I can already start finding the equation of this. I'd recommend pausing the video to try and figure that one out on your own. So you should have the y is equal to a times x minus h, which is the 4 squared, plus k. If you used factored form, you'll still end up with the same answer. I'm just going to stick to the vertex form though. So we've got our a, we need to figure out what our a value is. I like to use the origin because that tells me the coordinates 0, 0. So I'm going to replace that for my x and y, keeping the a. And then I can simplify down the 0 minus 4 squared, which is 16. And this is where students commonly make the mistake because they think 16 plus 32 is the next step, but that's 16a plus the 32. So I need to subtract the 32 before I can do any combination with the 16. So this is negative 32 is equal to 16a. So when I divide both sides by 16, I get that a is negative 2. So now I've got my equation for the quadratic function. I've got the negative 2 times x minus 4 squared plus 32. I can continue and see that at the same time, a bird is flying linearly off of a 20-inch tall box. So let's see, it starts off on the 20 inches. And that's how tall the box is. And it gains 2 inches of altitude every second. So that's my rise over run. So it's going up by 2, running by 1 each time. Well, that should be a little longer for the 2. So then we can look and see that the y equals mx plus b form would be y is equal to gaining 2 inches, and it's starting at 20. So this creates my little system of equations with these two equations here that I can then set up an equation to solve. Since I know what y is for both of them, I can just set both expressions equal to each other. So negative 2 times x minus 4 squared plus 32 is equal to the 2x plus 20. So I'm going to start by multiplying out the x minus 4 squared by doing the box on that. So I'm going to let you all take a moment to pause the video to try that out. We should be getting negative 2 times x squared minus 8x plus 16. The common mistake that we make is to think that it's just x squared plus 16, but that is false. We need to remember that whenever there's a plus or minus sign with an exponent, we need to use the box method. We can then distribute the negative 2 to all terms. So I'm going to have the negative 2x squared plus 16x minus 32 plus 32 equals 2x plus 20. And I'm going to move all of my terms over to the right, but as you can see, these two terms will cancel out. That's a pattern that you're going to see a lot of throughout this. So we're going to add, I'm going to move my, you don't have to move it to this side, but I like to keep my x squared positive. So I'm going to add the 2x squared and subtract 16x to get a 0, adding 2x squared and subtracting 16x. So that gives me a 0 on the left, with 2x squared minus 14x plus 20 on the right. And before I do box diamond, I'm actually going to simplify both sides by 2 and get 0 is equal to x squared minus 7x plus 10. So take a moment to pause the video to do box diamond on this. We should be getting, so this again is taking the box and diamond method, x minus 2 and x minus 5 as our two factors, which means that when we set the factors equal to 0 as for the zero product property, we get x is positive 2 and x is positive 5. We also want to figure out what our y value is, so I'm just going to use that equation and substitute that in. 2 times 2 plus 20, and 2 times 5 plus 20. So my y value in this case would be 24, and in this case would be 30. And I did put answers up there for you to check your work, but word problems we always want to answer in a complete sentence. So at what times were they at the same height, and what are those heights? So at, what's my x value? First x value is 2, so at 2 seconds, they were 24 units are meters? No, inches. Inches high. And at, what's the other one? 5 seconds, they were 30 inches high. So I'll do one more problem from this, and then the last few or 2 problems are going to be for you to work on in class. So we've got a punter kicks the ball, and it reaches a maximum height of 1.86 meters and lands 3.8 seconds. So once again, using the assumption that we've got one quadratic, one linear, we're going to be setting this up with the maximum height being at 1.86, landing 3.8. So as you can see, we've got some nasty decimals. Dividing it by 2 gives me 1.9, which means my vertex is at 1.9, 1.86. So my vertex form will have the x minus h, 1.9, squared, plus the k, which is 1.86. And I need to stick my little a value in there. So my x and y, again, I'm just going to use that origin. You can use any other point other than the vertex to find it, but I like to stick in zeros because it makes it a little bit easier. So I'm going to start with my squaring of this and simplifying that down. And looking at my notes, we get, I did not write that down. Darn, I think it's 3.61, right? 3.61 for the a value. And then when I subtract the 1.86 from both sides, and then divide by the 3.61, I'm going to round my decimal to 3 decimal places, negative 0.515. And so that means my equation is negative 0.515 x minus 1.9 squared plus 1.86. The second part, meanwhile, a blocker's hand went up along a path that would have started at 4.26 meters high, 4.26, and then dropping 1.43 meters every second. So we're going down like that. So that means that's my slope. And this is the y-intercept. So my y is equal to, and it's dropping, so it's a negative slope, negative 1.43x, and then plus 4.26. So we can set these equal to each other using the exact same methods. You're just going to have bigger decimal values. So we are going to start with squaring out that x minus 1.9 first. And then we'll simplify and solve from there. So again, I do encourage you to pause the video, maybe skip forward if you're feeling confident in how to solve this. I do have the answers up there, though. We'll see why we can't include that one in just a moment. So take a moment, box this one out with your x minus 1.9 and x minus 1.9. Definitely need a calculator for that. We should be getting negative 0.515 times x squared minus 3.8x plus 3.61. Oops. And then plus the 1.86. And then we can distribute that to all 3 terms. So negative 0.515 x squared plus 1.957 x minus 1.86 plus 1.86 after we round. And that's still negative 1.43x plus 4.26. And once again, those will cancel. And I like to keep my a values positive, so I'm going to move this over. And when we simplify things down, we get a 0 on one side and then 0.515x squared. These two will combine to make negative 3.387x and then plus 4.26. Now, when we divide everything by that a value, it doesn't end up being a nice term, whole integers for the other values. So we do not go on with simplifying from there to use the box and diamond. I would just jump right into the negative b plus or minus square root of b squared minus 4ac all over 2a. So again, pausing the video to try this on your own. You are going to get a lot of nasty little decimals, but it will work out all in the end. So my a value is 0.515. My b value is negative 3.387. And my c value is 4.26. So we're going to be substituting those into this formula here. So negative 3.87 plus or minus the square root of, and keep that in parentheses when you enter that in your calculator, 387 squared minus 4 times a, which is 0.515. C is 4.26, all over 2a, 0.515. And so we can simplify these down. I like to simplify this part first, just underneath the square root. So I type that into my calculator just as it appears. I'm going to change that minus and negative into a positive, so 3.387 plus or minus. This square root, when we enter that into our calculator, should be 2.696. So that's, again, everything underneath the square root. And then 2 times 0.515 is 1.03. So then I like to take the square root of the 2.696, and I get 3.387 plus or minus 1.64. And then we're dividing that by 1.03. So entering that twice, 3.387 plus 1.64 all over 1.03. When I add, let's do that, 3.387 plus 1.64, I get 5.027. And then when I divide that by 1.03, I get 4.88. And that is one of the x values that we see up there. And again, we're going to see why I crossed it out, though, in just a moment. And so the second one, I have 3.387 minus 1.64 all over 1.03. And that simplifies down to 387 minus 1.64 is 1.747 divided by 1.03. And we get 1.69 or 1.696, right? So rounding should have really made it 1.7, but I think I was using the exact value of the square root when I saw that answer. So we've got two possible answers for our x values. So these are both x's. Let's go back up, substitute that into this nice linear function to get our y values. So this is going to be y is equal to negative 1.43 times the x, which is 4.88, plus the 20. And so when we get that, that was negative 1.43. Yeah. When we do that one, I have it up there. So when x is 4.88, we should be getting negative 2.72 for our y value. And then same idea with this one, the y is equal to negative 1.43 times the x value 1.696 plus the 20, which gave me around 1.84. So the reason why one of these is not accurate is because we are talking about how can the blocker knock down the punt? If so, at what time does this happen? And we knock down a punt when it's above ground, because a ball cannot go below ground. And a negative y value is telling us that it's going below the ground. So we cannot go. So the reason why we're crossing this one out is because we cannot go cannot go below ground. So the only answer is the punter or the blocker. So the blocker will be able to catch it. Will be able to, what's the phrase? The punter or the blocker will be able to knock down the punt. Blocker will be able to knock down the punt. At what time? So the time was the X value, so 1.696 seconds. And it would be at that height as well, but it was just asking for at what time, right? At what time. Awesome. So you've got some other problems to practice through as well and some answers to check your work as you go. Looks like we'll be using Pythagorean theorem again, or not Pythagorean theorem, quadratic formula again to tackle those questions.